Hey, what's up guys, this is Paul the auto technician from Paul Nash Auto's garage, and today I'm diagnosing a 2010 Toyota Vitz that had electrical problems on the onboard electrical system of the car. Previously installed in the middle of the street, all the lights were flashing on the instrument cluster. It literally looked like a Christmas tree. We brought the car to the garage and we did some little bit of diagnosis on the system. The car has a battery problem. The battery has been severely degraded. We're going to do tests on the car, and from those tests we are going to make a determination and do a battery swap. And if we don't get to the point of swapping the battery, like I don't show you on this video, we'll already have the information required. And in future, when you are faced with such circumstances, you'll be able to diagnose the problem and do the appropriate fix. So join me on board. If this is your first time on this channel, kindly subscribe, hit the like button, like this video, put some comments down there below, and by doing so you'll support this channel in a much bigger way. Okay, so I'm going to hook up my dongle on this OBD2 port so that we scan for the codes, the trouble codes, the system first before doing anything. Okay, then I come to my scan tool here and start the diagnosis process. Alright, so it's Asian, it's a Toyota. Okay, this will give me the information that I need first hand. So it's a 16-pin DLC Japan. It's a Vitz, right? It was made between the year 2010 and 2012. It has a smart key. Okay, this is the information pertaining that vehicle. This is the mileage that the vehicle has traveled, and it's in the units of kilometers. So I'm going to click OK, and then we're going to read the codes. Alright, we're going to smart scan the whole system, extract any trouble code that might be on board the electrical systems of this vehicle. Okay guys, so I've connected my output from the PCM, the ECM, to the voltage regulator of the alternator. This will be a command. It's an on and off signal command to control the output of the voltage regulator of this alternator. This is a smart alternator, and this is my ground right here on the casing of the alternator. So these are my leads here. This is my ground, the one that I'm connected to the casing of the alternator, and this is the signal from the ECM. Okay, so now the engine is running. You can see the battery light is on. Alright, so this is our topology scan. Let us go ahead and read these codes. This is it has the code for the deterioration of the battery. That's the P1602. And then when you come to the ABS, it has low or high power supply voltage. Okay, this one here for the SRS, we'll take care of them later. And also this one. So if we get into the system, we want to do the data streaming right here. And first of all, we select the battery module voltage, right, and then the alternator output duty. Okay, then we select OK. Then this is our data right here. just check out how low that battery voltage is. The output duty cycle of the alternator is 31%. When you come here to my scope, this is the capture that I've captured. I want us to compare the data back to back, okay? So if I stop this capture right here, then I pull in my rulers. This is the phase rulers, okay? So what happens is that this rising edge here of capture, the rising edge here, this one here is where the frequency began, okay? Frequency in terms of hertz, right? Now this one here, up to that one here, that's 100%, okay? It's 100% control. So how this is calculated is, now we pull the other rulers. Now here, this is 0. Let me zero that value. Here, let me zero that value, okay? And then I pull in the other cursor right here. How much is that? About 27%, okay? So that is close to what my scan tool is telling me. Remember, the scan tool is showing me 31%, okay? And this one is about 27%, 26, 27%. So it's close. It's closely matching my scan tool, my scan data right here. What this shows me is that the alternator the output duty cycle of the alternator is low, because the alternator has realized that even if it outputs full charge to the system, the battery doesn't have the capacitance to hold that charge, okay? So for that reason, that's why the output duty cycle is that low, right? That's why it gets that low. And when you look at my voltage, the voltage is 7.4 volts. And when you look at it here, it's 9 volt, okay? Down here, it's 8 volts, 8.9 volts. This vehicle is going to need a new battery installed on the system. And if I don't get back to show you the fix, because I don't know the time the owner will decide to buy that battery. If I don't get back, you've already seen the understanding of how to troubleshoot for a low voltage problem on the system, okay? Yeah, to avoid the confusion, you know, someone might even go ahead and replace the complete unit of the alternator and other electrical components on the system, but that is not the major problem. The problem that we have here is the battery. Our battery has deteriorated, and that's why we received that code from our scan tool, okay? Alright guys, we've gone through the system of the little Vitz, and we've seen the electrical system has a problem, and that's why sometimes the vehicle is suddenly shutting down in the middle of the traffic, or even in the middle of nowhere, like the last time I went for the rescue of this particular little Vitz. And I've shown you how to capture that data and how you can use that data to diagnose any fault in the system. See you on the next one.